If you've been waiting for a follow-up to my video about the installation of this M-DRO, I must apologise for how long it's taken. I didn't really want to do it after the installation because it's so cold in here, and then I had a period of being extremely busy, and when I finally got around to it, it was summer and the temperature in here was about 36 degrees, so again I put it off for a time. Anyway, now the weather's settled down to normal English summer, i.e. raining, so I better get on with it. So once you have installed your DRO, you need to set it up, and to do that you need the setup manual here, and you enter the setup manual by powering up the console and pressing the enter key, like so. It's asking you to select the type. By type it means how many axes do you have on your machine. You press enter, it will ask you to input a number. We have 2 axes here. Okay, carry on to the next. Direction. You use direction to indicate whether the readings are positive or negative, depending on which way the carriage or the cross slide is moving. So to do that, press enter, and here we have the select the axis X is a 1, and we select Z is a 0. Moving on to the next setting, compensation type. There are 2 types of compensation you can apply if you have errors in your system. You can either use the linear compensation, which affects the whole of the travel of the sensors, or you can segment it and apply different compensations to different sections of the encoder. The next setting is R&D, radius or diameter, and you can set each axis to either read as a radius or a diameter. I'll show you that function later on. The next setting is called Z-dial or Z-axis simulation, or if you're in America, Z-axis simulation. And what it does is it stores a parameter which is the amount of travel for each revolution of the dial, either on the cross slide or the carriage. The next setting is resolution. This allows you to set the resolution of the system. At the moment mine is set to 5 microns, which is the resolution of the encoders I bought. You can buy better resolution or lower resolution sensors, but there's no point in setting the resolution on here to something that you don't actually have, because it won't give you better resolution, it will just make your results inaccurate. This console is a universal one in that it's used on lathes and milling machines, so there are a number of other functions which you can access through here which are not really applicable to lathe use. Axis type is one, step mode, angle mode, generally used for milling, type of angle, setting up an error. Oh, you can go into lathe mode. Oh, that is clear all the values and quit. If you quit now, if you go back to clear all, you'll go back to factory defaults, and then quit. And we're back to the user controls. Let's have a quick look at some of the other functions of the console. This section here is a calculator. It's got trig functions and square roots and so on, and calculations made on here can be switched directly to the axes. There's a half function here which you can use for finding the center. There's an increment to absolute switch, so You can use a fixed datum, or you can indicate increments from a fixed position. The tool store allows you to store offsets from up to 200 tools. So if you have a quick change tool post, you can enter the offsets for each tool you've got mounted. This key allows you to indicate either in radius or diameters. This measurement function here is for measuring the slope of a taper, but you need an external dial gauge to be able to use that. Finally, there's an inch and metric key, switching between the two. Very handy for me because my lathe is imperial, but I mostly work in metric. Let's make up an example for you. Supposing you have an imperial lathe, like I do, and you have a piece of 1-inch bar stock that you need to turn down to, say, 16 millimeters, and you only have an imperial micrometer. Now what you would do is mount your piece of bar in the chuck or collet and bring the tool up to just touch the workpiece, then zero the axis. Now make sure you're in D for diameter mode. That's this key here, which switches between radius and diameter. And use your micrometer to measure the diameter of your workpiece. Then go into calculator mode and enter the actual measurement of the diameter of your workpiece. Say it's 1.02 inches. You can then enter that into the axis for the cross slide, like so. Now come out of calculator mode, make sure in diameter, and press the inch to millimeter conversion. 25.908 millimeters. Now what you need to do is start your lathe and start turning down, taking cuts until you get an indication of 16 millimeters on the readout. And that will be the diameter that you need, or a little less than the diameter you need in this case, but it's only an example. When you buy a M-DRO system, you'll find that the supplier will only specify the resolution being the smallest change in position that the system can indicate. The reason he does this is that he's no idea what you're going to fit the system to. So the machine you fit it to may have all sorts of other defects which will change the accuracy and precision. And it's accuracy and precision that we're really interested in, so I'll show you how to measure those. When you measure something and compare your measurement with the true value of what you're measuring, the difference is known as the accuracy. And if you determine the accuracy a number of times and compute the scatter of your results, that's known as the precision. Now if you're going to measure accuracy, you're going to need some sort of standard which you can measure, which is a known value. Now one of the things you can use are things like this. These are called slip gauges or gauge blocks, and what they are just pieces of steel that have been measured to a very high degree of accuracy by some sort of standardising body. In my case it's the National Physical Laboratory in the UK. Now these can be obtained in a number of different thicknesses, but the problem is they're quite expensive to buy any number of them, so most people only have a very limited number. Now to measure my gauge blocks, what I've done is I've set up this block here on a magnetic base fixed to the bed and backed up against the chuck, and I'm going to squeeze the gauge block between the tool holder here and this block, so I can move the cage in, move the carriage in and squeeze up here. The first thing to do is establish the 0 point, and to do that I move the carriage forward until the block is hit by the tool holder. So 0 position. Now I can move the carriage back and put my first gauge block into position. This one is 4.0 millimeters. .995. Now if we do this several times and note the readings, we can calculate the scatter of the results. This one dead on 4.000. Next gauge block is 2.000 millimeters. Spot on. Take it out, put it back, do it again. This is 1.01 millimeters. And finally 0.41 millimeters. Okay. Well, I'm quite happy with the accuracy at these low levels. Now, before you start writing on the comments box, I'm quite aware that you shouldn't handle these things with your fingers, because the heat of your hands will cause them to warm up and they will change dimensions. So you really should handle them with tweezers like this. But this video is long enough as it is, and I don't really want you to spend ages looking at me fiddling around, dropping these things all over the place. So apologies for that, but at least you get the general idea of how to assess the accuracy of your system. You might wonder if I ever do anything except make videos. Well, I should tell you that this lathe is just another workshop tool that I use to support my main hobby, which is shooting antique rifles. So I'm not a model maker. I'm not going to be able to show you a magnificent steam locomotive I just knocked up, but here's a couple of things I do. This is a 4570 cartridge case, which I need to modify to fit in a 4560 caliber antique rifle. Now, to do that, I've already moved 0.2 inches off this end using a chop saw, which is very easy to do, but now I need to remove 0.126 millimeters from the inside rim of the back of the case. The reason I have to do that is that it won't chamber in the rifle with the currently rimmed, because it's too thick. So to do that, I just chuck it in a collet like so, tighten it up, then bring the tool up behind the rim, bring it forward until it just touches the case, then bring it up to the rim, touching the back of the rim like that. 0 the axis, then I can just start the lathe and bring the tool forward until 0.126 is indicated on the display here, and that is the amount of cut I've made. Here's something else I made since fitting the DRO. This is a press for loading the cylinders on percussion revolvers, but it involved quite a lot of turning and milling these slots here and milling this down here, positioning for the holes and so on. So the DRO was very useful in this endeavour, and of course to make it I had to use this milling slide, which is made to fit on the Myford, which allows you to do milling on the lathe. So what are the advantages I found with the DRO system? Well, firstly, it's much more difficult to read this than it is to read this. Secondly, look how much backlash there is in the cross slide before the system responds. With the DRO, it only responds to actual movement of the components, so backlash is irrelevant. So what are my impressions so far? Well, the system makes a better machinist out of a not very good one. It's much quicker to use than fiddling around with the dials on the machine. It's very good if you have an imperial machine and want to work in metric. It's an English company, although the parts are probably made in China. It's supplied by a UK company. The documentation is extremely good. Their after-sales service is very good. Their website has videos on how to use all the various features of this DRO. Was it worth the money? To me, yes. Is it the best system you can get? I have no idea, but it's a very good one as far as I'm concerned. And it's very easy to fit, so if you're not into scratching around making your own mounting components, then I thoroughly recommend it. Finally, I need to say that I have no connection with M-DRO or the Allendale Group other than as a satisfied customer.